But today we're going to talk about triangles on the coordinate plane. And so the first question says, find the values of the 6 trigonometric functions for angle theta in standard position if a point with coordinate 3, -4 lies on its terminal side. Well, for all you know, I'm speaking a different language probably when you see those words. But we want to fill in what sine and cosine and tangent and some other values that we'll talk about in a couple minutes are. But let's start by drawing a picture. We're drawing a picture. So we draw our coordinate plane, and hopefully yours looks better than mine. So here's our initial side. But where does the coordinate 3, -4 lie? In other words, what quadrant is 3, -4 in? It's in the 4th quadrant. We went right 3, and then we went down 4. And so in other words, when we draw this picture, we're going to end up over here. And I missed the point there, but we'll get this a little bit. So what we're going to do is we're always going to connect back to the x-axis. And what we did here, this point is 3, -4. That means that we went right 3 spaces, and we went down 4 spaces. So the base of our triangle is 3. The height of the triangle, it's not really -4. The negative means that we're going in the downward direction. So we're going to write the -4 there. And what we need to figure out is, well, what's the length of this hypotenuse? And it is a right triangle here. Well, any ideas on how to calculate the length of the hypotenuse? Gracie? Close. A squared plus b squared equals c squared. Pythagorean theorem, for all intents and purposes. And what we're going to do, the Pythagorean theorem says side squared plus side squared equals hypotenuse squared. So we're going to fill in, it's going to be 3 squared plus -4 squared equals c squared. It does not matter if you put the 3 in for A and the -4 in for B, or vice versa. Side squared plus side squared equals hypotenuse squared. Well, 3 squared is 3 times 3, which is 9. -4 squared is -4 times -4, which is 16. So we get 9 plus 16 is 25. And now we can take the square root of both sides. And the square root of 25 is 5. Technically, it would be plus or minus 5. But since we're really dealing with the distance, Nicole, we just want to deal with the positive value. But that's why I said, I know that this is a distance here. The 4 is a distance. The negative is telling us that we're going in the downward direction on that. So if we fill in now our hypotenuse of 5, I want to go back and refresh your memory on something else. Because not only are we talking about sine and cosine today, but we also see tangent as part of this. So back in geometry, we said that sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite over adjacent. Now, some of you have even told me I hated trigonometry, and hate was the word, I think, in geometry. But let me try to help you understand it a little bit more. When we are figuring out something like sine or cosine or tangent in here, it's helpful if we label the different parts of the triangle. Our angle that we're working with is here. And across from that angle is the opposite length. Well, we just found the hypotenuse, which is across from our box there. And not the hup, but the height here, hypotenuse. Which means that there's only one more part to our triangle, the 3, which is the adjacent side. And if we know this SOHCAHTOA, which they use a lot in geometry, Gracie? How did I know? One more time. It always connects back to the origin.
But that's always going to be the angle we're on.
Yes. So our angle's going to be touching the origin somehow there, or it's going to form around the origin somehow. If we know that mnemonic again, sine is the opposite length divided by the hypotenuse. So in this case here, when we want to find the values, sine is opposite, which is -4, divided by the hypotenuse, which is 5. Cosine is the adjacent divided by the hypotenuse. Well, we've labeled our triangle, the adjacent length is 3, and our hypotenuse is 5. The tangent is opposite divided by the adjacent. Our opposite length is -4, and our hypotenuse is 5. And before we get into this other stuff over here to the right, so I said that tangent is opposite over adjacent, but I didn't write it as opposite over adjacent, so opposite is -4, but the adjacent is really 3. We'll get that fixed. But before we get back into this other stuff to the right here, I just want to point out that we talked about all students taking calculus. Notice that in the 4th quadrant here, our cosine function is positive, and the other 2 functions are negative. Just an aside to something that we've talked about already. But what we have over here to the right are the reciprocal functions to sine and cosine and tangent. The first one is cosecant. C-O-S-E-C-A-N-T. And the cosecant of theta, again, is the reciprocal of sine. So we know our sine value is -4/5, which means that our cosecant value is going to be -5/4. We took the reciprocal of that fraction. The numerator became the denominator became the numerator. The next function here, secant of theta, is the reciprocal. Secant is the reciprocal of cosine. We know that cosine is 3/5, so the reciprocal for secant is going to be 5/3. And the reciprocal of tangent is called cotangent. I'm going to write it underneath because I'm running out of room. It's cotangent, but it's the reciprocal function. So our tangent value is -4/3. The reciprocal of that is going to be -3/4. Find the values of the 6 trigonometric functions for angle theta in standard position if a point with the coordinate negative the square root of 3, comma 1 lies on its terminal side. So let's draw a picture again. But the first thing to look at here essentially is what quadrant is negative the square root of 3, comma 1 in? If we were drawing here, we go to the left, negative radical 3, and we go up 1. So that's going to put us in quadrant 2. Here's our initial side. Here's our terminal side. Hopefully your picture's better than mine. Woo. There's our terminal side. We always connect back to the x-axis. So I have to draw this again. Always connect back to the x-axis. Here's our right angle. This point right here is negative the square root of 3, 1. Gracie, here's our angle. Right there. Touching the origin. We went, in this triangle, we went left the square root of 3. That's why it's negative. The negative is giving us the direction there. And then we went up 1. What we need to figure out is, what's the value of the hypotenuse? Going to use the Pythagorean theorem again. So we're going to take a squared plus b squared equals c squared. And again, it doesn't matter. Negative square root of 3 squared plus 1 squared equals c squared. Well, just a reminder here. Negative radical 3 squared means negative radical 3 times negative radical 3. Negative times negative is positive. Square root of 3 times square root of 3 is square root of 9. What's the square root of 9? So negative the square root of 3 squared is simply 3. 1 squared is 1 times 1. So when we simplify that a little bit more, we end up with 3 plus 1, which works out pretty well for us because 3 plus 1 is 4 equals c squared. And we can take the square root of both sides, and we end up with c equals 2. That's going to be the length of our hypotenuse. So we can fill that back in. And let's label. Across from our angle, the 1 is the opposite. I don't know why I wrote the 2 in black, but across from the right angle, there's our hypotenuse. Again, keep writing HUP instead of HYP, which means that our remaining side length must be the adjacent. And I personally find it helpful to label sides of the triangle. Now we have a little bit more working knowledge to fill in our sine, cosine, tangent, along with our cosecant, secant, and cotangent. Sine is the opposite divided by the hypotenuse. Try to fill it in correctly this time. Cosine is the adjacent divided by the hypotenuse. Tangent is the opposite divided by the adjacent, and here's where I really want to write this in. So if you want to get technical, opposite is 1 and the adjacent is negative square root of 3. And technically, we don't like having a radical in the denominator. But before we get that radical out of the denominator, let's go ahead and look at the reciprocals. And then we can talk about how to get a radical out of the denominator. Well, once again, the reciprocal of sine is cosecant. So 1 over 2 has a reciprocal of 2 over 1, no, you don't have to write the 1. The reciprocal of 1/2 is 2. Secant is the reciprocal of cosine, so we can take 2 divided by negative square root of 3. There's the reciprocal. The reciprocal of tangent is cotangent. We have 1 divided by negative square root of 3. Negative square root of 3 divided by 1. No, you don't have to write the 1. But there's our functions. We need to fix them up a little bit more. We need to get rid of the radical in the denominator. And the way that we do that is we're going to multiply whatever the denominator is by itself. We're going to multiply by negative radical 3. But if we multiply by negative radical 3 in the denominator, we have to multiply by negative square root of 3 in the numerator also. When we do that, remember we multiply the tops together, so we get 1 times negative the square root of 3, which is negative square root of 3. And if you look closely here in the denominator, we already know what this is. It's negative the square root of 3 times negative the square root of 3. If we look back in our Pythagorean theorem, we had negative the square root of 3 times negative square root of 3. And when we simplified that, we ended up with the square root of 9, which is simply 3. So tangent of theta is really negative the square root of 3 over 3. We want to get rid of the radical in the denominator. And we have one more function that also needs to be dealt with here, and that is our secant function. I know we can't see it right now, but our secant function, I'm going to draw an arrow down here because I don't have enough space, is 2 over the square root of negative 3. And the process is going to be the same. We want to get rid of the radical in the denominator, so we're going to multiply by negative the square root of 3 in the denominator. And if we multiply the bottom of the fraction by that value, we're going to multiply the top of that fraction by that value as well. And we end up with negative 2 radical 3. And again, here's the same math that we did in the Pythagorean theorem. Negative the square root of 3 times negative the square root of 3. Negative times negative is positive. And in fact, it's the square root of 9. And then once the square root of 9, it's 3. I'm going to put that back into our secant function. If I can. Negative 2 radical 3 over 3. So the nice thing is, if we can figure out what quadrant we're working with, and we can find the value of the hypotenuse, then we can identify the different values, different trigonometric values. So one more time, suppose theta is an angle in standard position, if tangent of theta equals the square root of 3, and sine of theta is less than 0, find the values of the remaining trigonometric functions of theta. Well, what does sine of theta less than 0 mean? Still speaking Francais. What does less than 0 mean?
0.
It means it's negative. So in other words, we need a quadrant where tangent is positive, because this is the square root of 3. The square root of 3 is positive, and sine is negative. So which of our 4 quadrants have tangent positive and sine negative? Well, a reminder, all students take calculus. In our 3rd quadrant, tangent is positive and all of the other functions are negative. That means sine and cosine are negative. So this means that we're going to be working in the third quadrant here. I'm going to switch that down because, ooh, maybe I am and maybe I'm not. Yeah, no. Get that out of the way is what I'm going to do. Because we need to draw the picture. And we're going to be in the third quadrant, like I said. And remember that tangent is opposite divided by the adjacent. So let's draw our triangle this time. Always connecting back to the x-axis. Our angle here touches the origin. And if we label this triangle, across from our angle is the opposite. Across from our right angle is the hypotenuse, which means that our remaining side is the adjacent. And again, tangent is opposite divided by the adjacent. So if we fill this in, tangent is the opposite length. Well, that's going to be the square root of 3 divided by the adjacent, which is 1. So we still have to find a hypotenuse. The thing is, in our third quadrant, if we go left, what's the sign on our 1 going to have to be? It'll have to be negative. And if we go downward, what's the sign on the square root of 3 have to be? It also has to be negative. Once we know that, then we can find our hypotenuse and then our function. So, negative 1 squared plus negative the square root of 3 squared equals c squared. Find a squared plus b squared equals c squared. Negative 1 squared means negative 1 times negative 1, which is 1. Negative the square root of 3. We just saw this on our last problem. But again, negative the square root of 3 times negative the square root of 3. Well, negative times negative is positive. 3 times 3 is 9. And the square root of 9 is 3. So this is really 1 plus 3 again equals c squared. One plus 3 is 4. We can take the square root of both sides. So c equals 2. We can go back and fill that in on our triangle. There's our 2. And then we can identify our functions. The good news is, we already know what tangent is. It's the square root of 3. We were given that. But as we look back at the others, sine. Sine is opposite divided by hypotenuse. Negative the square root of 3 divided by 2. Cosine is the adjacent over the hypotenuse. Negative 1 half. And then we need to find our reciprocal values. Cosecant is the reciprocal of sine. It's 2 divided by negative square root of 3. And in a minute, we'll get rid of that radical in the denominator. Secant is the reciprocal of negative 1 half. It's going to be negative 2. If you prefer, write negative 2 over 1. Cotangent is the reciprocal of tangent. This will be 1 divided by the square root of 3. And once again, we need to deal with the fact that there's a radical in the denominator. I can squeeze, well, I think I can squeeze them in. We'll try. In order to get rid of the radical here, we're going to multiply the denominator by negative radical 3. And if we multiply the bottom of the fraction by negative radical 3, we need to multiply the top of the fraction by negative radical 3. And when we do, we get negative 2 radical 3. And once again, a reminder, and we still have it over here in our Pythagorean theorem. Negative the square root of 3 times negative the square root of 3 is the square root of 9. And the square root of 9 is simply 3. As we finish, 1 divided by the square root of 3, we're going to multiply it by the square root of 3 here, and the square root of 3 here. 1 times the square root of 3 is the square root of 3. Square root of 3 times square root of 3. 2 of the same value to take out 1 gives us 3. You can't see that very well, so I'm going to try to scoot that over just a little bit better. There we go. Gives us square root of 3 over 3. Notice that we did end up with tangent being a positive value and sine being less than 0, which ends up to be a negative value.